Okay, more plate separation here. Job for Kane Hobbs. Viessmann 200 is 35 kilowatt. Heat calculation for the property was 45 kilowatts, but that's with on-off types controls and recovery. And we're taking a bit of a punt here. There's actually two boilers. This one's dedicated for hot water, but we're taking a punt that basically 35 kilowatts on weather comp will be enough to heat the house. And if it isn't, this boiler is due for replacement anyway. It's more than 2 years old and it's a Keston, so it's about time. I think it's about 10 years old. Heat exchanger on this one was on the way out at 10 years, or approximately 10 anyway. This one's going to be due for renewal, so if this isn't enough, then we'll obviously couple in the second boiler to top up the heating. However, if this is enough, we're actually going to try and run the hot water from it as well as the central heating, and if that fails, we'll put in the second boiler. But I've got a sneaky feeling we'll find that a 35 kilowatt boiler with weather comp will run the whole property and the hot water. Not really a gamble, because we were going to go for two boilers anyway. But it'll be a very interesting experiment. As I say, we did the whole house heat loss method for this property and came out at 45 kilowatts. Now, you might be aware, but the whole house heat loss method isn't suitable for houses of that size either, but actually I find it still reasonably accurate. Certainly for boiler sizing anyway, because you're always plumping for the next boiler up anyway. It's not let me down so far, but I think it's approved up to about 24 kilowatts, that method. So anyway, we can always get ourselves, rescue ourselves with the fact that we're always up for two boilers anyway. Okay, so plate separation. Now this might limit us a little bit, because obviously we've got a temperature drop across the plates, and also the radiators in the house might not be suited for this system completely. But anyway, I've got the secondary side running at DT9, so maybe the flow rate's a little bit high there, although we're not really the right weather to test it for the load, but and I can't actually test the flow. But DT9 as it is, and I've got 19 on the boiler, and I've worked out the arithmetic mean temperature difference, which is 6.5 full load at 35 kilowatts, and that's okay. It would probably be a bit lower if we actually had full load on the system, but it's quite a warm day today. So that's 6.5 would be acceptable in my book anyway. You get a sort of diminishing return as you go bigger with the plates. That's two Gledhill plates. These are, I believe, the bigger ones. You get two different sizes, and I think this is two of the bigger ones. It's a 2580 pump running the system, and that used to run the system with the boiler in line, and I would imagine that my twin plates are less head loss than the old boiler, but I don't know. So, expansion vessel on the system there. Customer had one of these large magma cleans anyway, and I wouldn't have fitted it if it wasn't already here. So that's in line. I've stuck a strainer in to stop the muck that doesn't get caught by the MagnaClean from getting into my plates, and I've made the plates all isolatable with valves here, and the boiler valves on there, so they can be taken off and cleaned relatively easy. So that's the job.